change is always the result from it's a chemical reaction which is taking place between the two substances. And the physical change is the one which is the change which is having only the change in the density, the melting point and the boiling point. So that and all we call it as a physical change. So the particular element or the compound, it does not change its properties, means it does not change into the another one. But in the chemical change, the whatever the element or the compound, it will completely change into the another substance. So here the processes in which the substance or the substances undergo the change to produces the new substances with the new chemical properties, that we call it as a chemical reactions. Say for example, the calcium carbonate is heated, so we will get the calcium oxide and the carbon dioxide. So calcium carbonate is CaCO3. So if we are heating that one, the CaO plus CO2. So the two things we will be getting. So CO2 is a gas and CO is the solid. So both are having the different properties from that of the CaCO3. So this we call it as a chemical reactions. So the breaking up of the calcium carbonate into the calcium oxide and the carbon dioxide is a chemical reaction in which, because so the calcium carbonate is converting it into the new substances. Okay. So what is meant by the reactant? So the reactant is the one which is a substance which takes place in the chemical reaction. So that we call it as a reactant. It means that the breaking up of the calcium carbonate into the calcium oxide and the carbon dioxide, in this one, calcium carbonate is undergoing the reaction. So that we call it as a reactant. So similarly, for example, suppose if the hydrogen and the water, oxygen is reacting to give the water. So hydrogen and the oxygen are the reactants. So whatever the metals or the elements or the compounds they are reacting, that we call it as a reactants. Products. So a product is a new substances which is formed from the chemical reactions. In this example, sodium and the water reacts to form the NaOH plus H2. So in this case, sodium reacts with the water. So these two are the reactants. And NaOH and the H2, these two are the products. So here, Na is the metal, water is a liquid. So these two are reacting, we are getting the gas. So the gas is completely different from that of the sodium and the water. And the sodium hydroxide, which is a NaOH, is a base, which is also completely different characteristics from the sodium and the water. So this we call it as a chemical reaction. Similarly, in the breaking up of the calcium carbonate CaCO3 into the calcium oxide and the CaO. So in this case, calcium oxide and the carbon dioxide are the products. Okay. So now the atoms in the molecule are held together by the force of the attraction. So that we call it as a bond. So usually the ionic bond is there, covalent bond is there. The ionic bond is between the metal and the non-metal. So it forms the positive charge and the negative charge. Then there is an attraction between the positive ion and the negative ion. The covalent bond is formed by the sharing of the electrons between the two non-metals. So that is the weak forces compared to that of the ionic bonding. So the molecules do not participate directly in the chemical reaction. So first we have to break it into the atoms. The molecule, in the sense, for example, if you are taking the oxygen, so oxygen molecule, it contains the two oxygen atoms, O double bond O. So first we have to break the bonds between the two oxygen atoms. So then the atom will come for the reaction. So we have to break into the atoms. Then the atom will take part in the reaction. The new bonds will be formed between the atoms to form the products. So these kind of the rearrangement or the regrouping, so it will leads to the formation of the products. Okay, so here ammonium cyanate, NH4N double bond C double bond O. So now here the rearrangement of the atoms takes place over here, and we are getting the urea, NH2 C double bond O NH2. So here The molecular formula of both the ammonium cyanate and the urea are the same. So here also it contains the two nitrogen, here also two nitrogen, one oxygen and four hydrogen. Here two hydrogen, here two hydrogen, so totally four hydrogen. So all the molecular formula of both the compounds are the same. So these compounds we call it as a isomers. It means that the compounds which are having the same molecular formula but different structural formula. So that we call it as a isomers. So these reactions, when we are converting one isomer to the other isomer, we call it as a isomerization reactions. Okay. Next one is the valency. So the valency is nothing but the number of the electrons can be shared by the one atom, that we call it as a valency. It also means that the combining capacity of an atom. Say for example, chlorine atom, Cl. So it has 7 electrons in the outermost shell, but it needs 1 electron to complete the octet. So 1 is the valency of the chlorine atom. Another example, oxygen. Oxygen is present in the group 6. It has 6 electrons in the outermost shell. It needs 2 electrons to complete the octet. So the 2 is the valency of the oxygen. Then nitrogen. Nitrogen is present in the group 5. It has the 5 electrons in the outermost shell. It needs 3 electrons to complete the octet. So the valency of the nitrogen is 3. Then the carbon. The carbon is present in the group 4. It has the 4 electrons in the outermost shell. So it can able to share the 4 electrons with the other atom. So the valency of the carbon is 4, like this. So here, if the carbon combines with the chlorine, so what will happen? So we know that the carbon is having the valency 4. Chlorine is having a valency 1. Both are not matched because this is 4 and this is 1. So we need to do the cross multiply. So the 1 we have to multiply it with the carbon, the 4 we have to multiply it with the chlorine. So CCl4. So this is the formula of the compound in which the carbon and the chlorine combines each other. Some more examples are H2O, water. So the hydrogen is having the valency 1, oxygen is having the valency 2. So both are different numbers. So we have to cross multiply it. So 2 we have to multiply it with the H, 1 we have to multiply it with the oxygen. So H2O, then HCl. In this case, hydrogen is having the valency 1, chlorine is having the valency 1. So in this case, both are 1 and 1. So when you are doing the cross multiplication, so we will get the HCl. Then another example is H2S, hydrogen sulfide. Hydrogen is having a valency 1, sulfur is having a 2. So here both the valencies are different. So we need to do the cross multiply. So 2 we have to multiply it with the hydrogen, 1 we have to multiply it with the sulfur. So H2S. Then ammonia. Nitrogen is having a valency 3, hydrogen is having the valency 1. We have to do the cross multiplication, so we'll get the NH3. PCl3, phosphorus trichloride. Phosphorus is having the valency 3, chlorine is having the valency 1, so we have to cross multiply PCl3. Then nitrogen pentoxide. Nitrogen is having a valency 5, oxygen is having the valency 2, so we need to do the cross multiplication, so N2O5. So these are all some common monoatomic ions they have given. So plus one charge. So this is the copper ion, that also we call it as a cuprous ion. It's having a valency 1, Cu plus 1. Potassium is present in the group 1, so it's a K plus. Silver ion Ag plus, sodium ion Na plus, lithium ion Li plus, Aries, that is nothing but the gold, Au plus. Plus 2 charge. Barium ion Ba2 plus, cobalt ion CO2 plus, strontium ion Sr2 plus, iron 2 ion, otherwise call it as the ferrous ion Fe2 plus, copper 2 ion Cu2 plus, lead-2 ion Pb2 plus, cadmium ion Cd2 plus, magnesium ion Mg2 plus, manganese 2 ion Mn plus 2, and mercury 1 ion Hg2 2 plus, and zinc ion Zn2 plus. Plus 3 charges, aluminium ion Al3 plus, auric ion Au plus 3, and chromium 3 ion Cr plus 3, and iron 3 ion, otherwise call it as a ferric ion Fe plus 3, and a scandium ion Sc plus 3, arsenic ion As plus 3, bismuth ion Bi plus 3, antimony ion Sb plus 3. So these are all the some of the common monoatomic ions. Monoatomic ion means the single atom can able to give the charge. Then next one is the negative charge, -1. So the -1 charge is normally given by the halogens. So bromide, fluoride, iodide, chloride. So these are all present to the group 7. So they need one more electron. So it will gain the one electron and it forms the -1 charge. Br minus, Cl minus, F minus, and I minus. -2 charge. So this is usually by the group 6 elements. Oxide ion O 2 minus, sulfide ion S 2 minus. -3 charge. So it is usually shown by the group 5. Nitride ion N 3 minus, phosphide ion P 3 minus, boride ion B 3 minus. Then polyatomic ions. So polyatomic means poly means many. So many atoms combines and it forms a charge -1, -2. So that we call it as a polyatomic ions. So here hydrogen carbonate or the bicarbonate. So hydrogen carbonate means HCO3 -1. So this -1 is common for all the HCO3, not only for the oxygen. HCO3 -1. Hydrogen sulfate HSO4 -1. Hydroxide ion OH -1. Nitrate ion NO3 -1. Chlorate ion ClO3 -1. Nitrite ion NO2 -1. Permanganate ion MnO4 -1. Acetate ion CH3COO -1. Cyanide ion Cn -1. Hypophosphite ion H2PO2 -1. Meta-aluminate ion AlO2 -1. Ammonium ion NH4 +1. Next one is the carbonate ion CO3 -2 charge. Manganate ion MnO4 -2 charge. Thiosulfate ion S2O3 -2. Silicate ion SiO3 -2. Sulfate SO4 -2 ion. Sulfide ion SO3 -2. Chromate ion CrO4 -2. Dichromate ion Cr2O7 -2. Hydrogen phosphate ion HPO4 -2. Oxalate ion C2O4 -2. So -3 charge, phosphate ion PO4 -3, arsenate ion ASO4 -3, and arsenite ion ASO3 -3, phosphite ion PO3 -3, borate ion BO3 -3, ferricyanide ion FeCN6 -3. Then -4 charges the carbide ion C4 minus, then ferrocyanide ion FeCN6 4 minus. Now, test of the chemical reaction. So if the chemical reaction has to happen, so it has to satisfy the following points. So either it should gives out the heat or it has to take up the heat. Okay, so definitely we can able to measure the change in the temperature. If the heat is given out, the temperature will be higher. If the heat is taken up, the temperature will be the low. Then the reaction must occur between the fixed quantities of the reactants. So whatever the quantities we have taken, that should occur. The reaction should take place between the fixed quantities. Then there must not be either gain or loss of matter. So a chemical reaction should follow the law of conservation of mass. So whatever the mass of the reactants you have taken, the same amount of the mass it should convert it into the products. So the products obtained as a result of the chemical reaction must have the properties different from those of the reactants. That's what it will create the new substance. Then the properties will differ from the reactants. All the chemical reactions are represented by the chemical equations. So using the chemical reactions, we can able to identify which one is the reactant, which one is the product, and whether the heat is taken place or not, or whether the catalyst we have used it or not. So these are all the basic informations we can able to get it from the chemical reaction. So it is a shorthand representation of the chemical reaction using the symbols, and also we can able to identify whether the particular reactants or the products is a solid, liquid or gas or the aqueous solutions. So these are all the informations we can get it from that. Example, KNO3 gives KNO2 plus O2. KNO3 is potassium nitrate is decomposed to give the potassium nitrite plus oxygen. So in this case, potassium nitrate, so it releases one of the O2. So this is the solid. So when we are heating it, that one of the gas is released. So definitely here the some chemical reaction taken place. Then the zinc plus H2SO4. So we will be getting the bubbles because the hydrogen is a gas. So the gas will be released and we will get the ZnSO4. It's an aqueous solution. So what are the rules for writing the chemical equation? So the reactants which take part in the reaction are written in the terms of the symbols or the molecular formula on the left hand side of the equation. So always the reactants we have to write it in the left hand side. Then a plus symbol is added between the formulae of the reactants. Suppose one or more reactants are reacted in the particular reaction, so we have to use the plus sign between the two reactants. The product of the reaction are written in terms of their symbols or the molecular formula on the right hand side of the equation. So whatever the products we are getting, that we have to write it in the right hand side. A plus sign is added between the formulae of the products. Suppose if we are getting more than one product, we have to separate it using the plus sign. In between the reactants and the products, an arrow sign is inserted to show which way the reaction is occurring. So this is the give symbol. So this is the reactants. A plus B is the reactants and C plus D are the products. So A plus B together it reacted gives C plus D. So C plus D are the products. So the arrow mark shows that. So from this it's converted it into the C and the D. So balancing of the chemical equation. So balancing the chemical equation is an art and it is one of the important in the chemistry. Zn plus H2SO4 gives ZnSO4 plus H2. So now in this case, so we have to check that both sides the atoms are equal or not. So here one atom of the Zn is there. Here also only one Zn. And also here SO4 and SO4. So H2 and H2. So in this case, the atoms are completely balanced on the both sides. Okay. So now the next one is Na plus H2O gives NaOH plus H2. So in this case, here only one sodium atom, here also one sodium atom. Okay. And here H2. So whenever we are writing the 2 in the subscript, it belongs to the particular atom. So the 2 belongs to the hydrogen, not for the oxygen. So H2, there are 2 hydrogen atoms are there. So in the product side, so 1, 2, 3. There are 3 hydrogen atoms are there. So one of the hydrogen atom is excess in the product side. Then in the reactant we are having only one oxygen atom and in the product side we are having the one oxygen atom. So oxygen atom is balanced and also the sodium atom is balanced. but the hydrogen is not balanced. One hydrogen atom is excess in the product side. So we have to balance this equation. Okay. So now balanced equation means, so atoms of the various elements in the reactants and the products should be equal. So in this case, the equation 1 is completely balanced and the equation 2 is not balanced. Okay. So the reason for balancing the equations, why we have to balance the equation? Because the number of the atoms, or this we call it as the law of conservation of mass. So the number of the atoms, the elements whichever is reacting in the reactant side should be equal to the number of the atoms or molecules on the product side. So the balancing, the process of making atoms of the various elements equal in an equation on either side, we call it as a balancing. Okay. So now what are the steps we have to follow to balance the equation? So in this equation, we are having three atoms, sodium, hydrogen and oxygen. So Na, H and O. Here, number of atoms in the reactants, number of atoms in the products. Okay, the sodium is 1 over here, so we have written 1. And the product side, the sodium is 1, so this is 1. And hydrogen, here it is a 2 hydrogen atoms, so H2. And this side 1, 2, 3. So 3 atoms of the hydrogen are present. Oxygen is, here it is only 1 oxygen, so 1. Here it is also 1. Okay. So now in this case, sodium and oxygen are balanced, but the hydrogen is not balanced. So here in the reactant side it is 2, in the product side it is 3. Okay. So now pick an element to balance the equation in the. So sodium and oxygen are balanced, hydrogen is not. Okay. What we have to do is, so to balance the hydrogen on both sides, we have to multiply the H2O by 2, which makes the hydrogen atoms equal to the 4 on the reactant side. To make the hydrogen 4 on the product side, multiply NaOH by 2. So it's already here 2 hydrogen atoms are here. So here it is a totally 3, right? So we have to place the 2 here. When we are placing the 2 in front of the NaOH, we will get the 2 hydrogen atoms. So 2 NaOH. So we have to place the 2 H2O. So 2 H2O. So now we have to check it out. So here 4 hydrogen atoms, 2 H2O, and here also 2 plus 2, 4. Now the hydrogen atom is balanced and the oxygen 2 and also here is also 2. So oxygen is balanced. Then we have to check the sodium. Here it is a 1 and here it is the 2. Okay, so now we have to balance the sodium by placing the 2 in front of the sodium. So now 2Na plus H2O gives 2NaOH plus H2. So like this equation we need to balance. Next example is Fe plus H2O gives Fe3O4 plus H2. Okay, so now the elements present in the equation are Fe, hydrogen and the oxygen. So the number of the atoms in the reactants, so Fe is 1 and the hydrogen is 2 and the oxygen is 1. In the product side, there are 3 Fe atoms are present, 3 and hydrogen is 2 and the oxygen is 4. So now what will happen? The iron atoms are not balanced and the oxygen atoms are not balanced. Only the hydrogen is balanced. So now we have to balance the iron and the oxygen. Okay. Now Fe plus H2 gives Fe3O4. Okay, fine. So now we have placed the oxygen is 1 over here, right? So we have to place the 4 in front of the H2O. So when we are placing the 4 in front of the H2O, we can able to balance the oxygen because here 4 oxygen atoms are there. So we have to place the 4 here. So whenever we are placing the 4, what will happen? The hydrogen atom is becoming 8. So again we have to place the 4 over here. So Fe plus 4H2O gives Fe3O4 plus H2. So now we have balanced the oxygen, 4 oxygen, and here also it is a 4 oxygen. Okay. Now next one is the hydrogen. Here there are 8 hydrogen atoms are there. But here there are 2 hydrogen atoms are there. So now we have to place the 4 in front of the H2. So 4H2. So now the equation is partially balanced with the oxygen and the hydrogen. Fe plus 4H2 gives Fe3O4 plus 4H2. So finally we have to balance the iron. In here we are having a Fe3. There are 3 iron atoms are there, but in the reactant side we are having only 1. So we have to add the 3 in front of the iron. So 3Fe plus 4H2O gives Fe3O4 plus 4H2O. So now we have balance of this equation. Okay. So in these equations, the charge balancing of the atoms on both sides of the equation. Okay. So now here, initially we are having a Cu plus 2 charge plus H2S gives Cus in the solid state plus H plus. Okay. So now here in this equation, so what's happening? So here it is 1 copper and 1 copper and 2 hydrogen, and here it is only 1 hydrogen is there, and only 1 sulfur, and it is a 1 sulfur. So now we have to balance the hydrogen. So Cu2 plus H2S gives Cus plus 2H plus. So we should not place the H2 here because the hydrogen is in the positive charge. So we have to place the 2 in front of the H plus. If we are placing the H2, it becomes a gas. So we should not change the equation. Always we have to balance the equation by writing the numbers in front of the atom or the molecule. We should not write in the subscript. Okay. So the compound sodium chloride. The formula for the sodium chloride is NaCl. So it contains the Na plus and the Cl minus. Magnesium chloride. The formula is MgCl2. So Mg is present in the group 2. So it is Mg plus 2 and the Cl minus. Magnesium oxide. So MgO, Mg2 plus plus O2 minus. Calcium chloride, CaCl2. Ca2 plus and the Cl minus. Calcium oxide, CaO, Ca2 plus plus oxygen 2 minus. Ammonium chloride, NH4Cl, NH4 plus and Cl minus. Barium chloride, BaCl2, Ba2 plus plus Cl minus. Potassium nitrate, KNO3, K plus and NO3 minus 1. Ammonium sulfate, NH4 twice SO4, so NH4 plus and SO4 2 minus. Cupric sulfate, CuSO4, it is a Cu2 plus and SO4 2 minus. Cupric chloride, CuCl2, Cu2 plus plus Cl minus. Then the electrovalency. So electrovalency is nothing but the element which forms the electrovalent bond. That valency we call it as a electrovalency. What does mean by electrovalent bond? So it is just combining the metal and the non-metal. So usually the metal or the metal will always lose the electrons and it becomes a positive charge. The non-metals always gain the electrons and it becomes a negative charge. So if the positive charge and the negative charge combines each other, that we call it as an electrovalency. So now here, the elements which loses the electrons, that we call it as a positive electrovalency, and those which gain the electrons, which will show the negative electrovalency. So for example, in the formation of the sodium chloride NaCl, the electrovalency of the sodium is +1, while that of the chlorine is -1. So here the 1 and the 1. So both are having the same number. So the formula is NaCl. If the numbers are changing over here, one is 1, another one is 2. So we have to cross multiply like we have done earlier. So the monovalent elements. Monovalent means the single charge. NaClF. Divalent elements. Divalent means it's having a charge 2. MgCaBaO. trivalent element, so it's having a charge 3, AlB. Characteristics of the electrovalent or the ionic compounds. So the electrovalent compounds are made up of the positively and the negatively charged ions. Say for example, sodium chloride NaCl, it is made up of the Na plus and the Cl minus ions. So it is arranged in a definite order in the 3 dimensions to form the crystals. Always the ionic compounds exist in the form of the crystal. Electrovalent compounds have high melting and boiling points because it's having a strong electrovalent forces between the positive and the negative ions. A large amount of the heat energy we have to supply to break the forces of the attraction. So that's why the melting and the boiling point of the electrovalent compounds are quite high. Electrovalent compounds are usually soluble in the water but insoluble in the organic solvents such as benzene, acetone, carbon disulfide and carbon tetrachloride. The electrovalent compounds can conduct electricity in the molten state. So what is meant by molten state? It's just a liquid state. So we have melted the solid to the liquid. So that we call it as a molten state. And the aqueous solutions means the electrovalent compound we have dissolved in the water. So NaCl, if you're dissolved in the water, that we call it as an aqueous solution. In solid electrovalent compounds, the ions are held together in the fixed positions and so they cannot move. So in the solid state, they do not conduct the electricity. But the same electrovalent compound, when it is in the liquid state or it is in the molten state, they can able to conduct the electricity because the ions which is present in that can able to move freely. So the ionic compounds in the molten state or in the solution becomes the conductors of the electricity. But as well as in the solid state, they do not conduct the electricity. Next one is the covalent bond. The covalent bond is nothing but between the two atoms, it will share the electrons. And we call it as a covalent bond. The sharing of electrons between the two atoms takes place when the atom requires the stable electronic configuration of the nearest noble gases. So here there are 3 types of the covalent bonds are there. Single covalent bond, double covalent bond and triple covalent bond. Single covalent bond is formed when only one pair of electrons is shared between the two atoms. Say for example, formation of the hydrogen molecule H2. So a molecule of hydrogen consists of the 2 hydrogen atoms. So each hydrogen atom has only one electron in the outermost shell. When the 2 hydrogen atoms are combined, so one electron from one of the hydrogen atom will make a involve in the sharing. So now the 2 electrons are shared between the 2 atoms. See here, hydrogen is having only one electron. So this hydrogen atom is also having the one electron. Now these 2 electrons are shared between the 2 atoms, hydrogen, the pairs are shared hydrogen. So these 2 electrons will make a bond. This we call it as a single bond. Okay. Okay. So now next one is the formation of the methane molecule. So methane is nothing but carbon and the 4 hydrogen atoms. So a carbon atom has a valency of the 4 electrons in its outermost shell. So it can able to share the 4 electrons with the 4 atoms. So carbon is having 4 electrons. So now hydrogen we are going to combine. So hydrogen is having only 1 electron in the outermost shell. So we have to take the 4 hydrogen atoms to make the bonding with the 1 carbon atom. So now here carbon is making a single bond with the hydrogen, single bond with this hydrogen and single bond with this and single bond with this. So now this is the shape, this is the structure of the methane molecule, CH4. So each bond contains the 2 bonds which is shared between the 2 atoms. Double covalent bond. The double covalent bond is formed when two pairs of the electrons are shared between the two combining atoms. So, a sharing of the two pairs of electrons shown by the marking two short lines between the symbols of the two atoms. Example, oxygen, O2. So now, this is the one oxygen atom which is having the 6 electrons in the outermost shell. Here is the another oxygen atom which is having a 6 electrons in the outermost shell. So now this oxygen atom needs the 2 electrons. This oxygen atom needs the 2 electrons. So now this oxygen atom has to share the 2 electrons. This oxygen atom also share the 2 electrons. So see here, it's a sharing of electrons takes place between the two atoms. So this electron and this electron is making one bond, and this electron and this electron is making one bond. So in total, we are having a two bonds between the two oxygen atoms. This we call it as a double bond. Now, the formation of the ethylene molecule. Ethylene is nothing but C2H4. It belongs to the alkene family. In the formation of the ethylene molecule C2H4, each of the two carbon atoms combine with the two hydrogen atoms to form the two single covalent bonds. Okay, so now here we are having the two carbon atoms. So two carbon atoms, each carbon atom has 4 electrons in the outermost shell. And there are 4 hydrogen atoms are there. So 4 hydrogen is having a single electron in the outermost shell. So which gives, so the carbon and the carbon. So now one electron is shared with the one of the hydrogen, and the second electron is shared with the one of the hydrogen, and remaining the 2 electrons is shared with the carbon atom. Here also the same thing. So this carbon atom is one of the electron shared with the hydrogen, one of the electron is shared with the another hydrogen. The remaining 2 electrons is shared with the carbon. So in between the 2 carbon atoms, we are having the 4 electrons. So it will make the 2 bonds. So see, double bond C. Next one is triple covalent bond. Triple covalent bond is nothing but when 3 pairs of electrons are combined in between the 2 atoms. That we call it as a triple covalent bond. Say for example, N2. So now the nitrogen is having the 5 electrons in the outermost shell. So another nitrogen is also having the 5 electrons in the outermost shell. So this nitrogen needs the 3 electrons. This nitrogen needs the 3 electrons to complete the octet. If it needs the 3 electrons, it has to share the 3 electrons. So the nitrogen is sharing the 3 electrons from this side, and this nitrogen is also sharing the 3 electrons from this side. So both the nitrogen share totally 6 electrons. So now it forms a triple bond N, triple bond N. Okay, so now remaining these 2 electrons are there on the nitrogen. So this do not take part in the bonding. So this we call it as a lone pair of electrons. Next one is the formation of the acetylene molecule C2H2. So it is belongs to the alkyne family. So here the 2 carbon atoms are there. So each carbon atom is having a 4 electrons in the outermost shell. But here they are giving only the 2 hydrogen atoms. So each carbon will make a single bond with the 1 hydrogen atom like this. The remaining 3 electrons are shared between the 2 carbon atoms. So it makes a triple bond between the 3 carbon atoms and single bond with the hydrogen atoms. So what are the characteristics of the covalent compounds? So the covalent compounds are made up of the neutral molecules. So the force of the attraction between the molecules are weaker than those of the ionic compounds, because the ionic compounds we are having the electrostatic attraction between the positive ion and the negative ion. Here just that sharing of electrons takes place between the two atoms. So even though it is making a sharing, the electrons are having a negatively charged particles. So that there will be some repulsion takes place. So you can easily break a bond between the two atoms. And also most of the covalent compounds exist as a gas, say for example O2, N2 and all. So the melting and boiling points of the covalent compounds are generally low. Since the covalent compounds are made of the neutral molecules, the force of attraction between the molecules are very weak. So comparatively, the small amount of the heat energy is required to break the weak intermolecular forces of attraction. So they have the low melting and the boiling points. The covalent compounds are insoluble in water but soluble in the organic solvents. Covalent compounds, they do not conduct the electricity because they do not contain any ions or the free electrons. It's just the sharing of electrons between the two atoms. They are made up of the neutral molecules, not ions, and not produce ions in the molten state or in the aqueous solutions. Then bonding in metals. So the metals are hot solids and they are made up of the atoms. So the atoms in the metal are very closely packed together. We call it as a lattice. The force that holds the atoms closer together in a metal is known as the metallic bond. So the metal always lose the electrons. Either it is having a one electron means it will lose the one electron. If it's having a two electrons in the outermost shell, it loses the two. If it is a three, then it will lose the three electrons. Depends upon the how many electrons present in the outermost shell. So now the force between the free electrons and the positively charged the metal ions, we call it as a metallic bonding. So the electrons are free, it can able to move freely all over the metal. So that's why we call it as a free electrons. And also the metals can easily conduct the electricity even in the solid state. Why? Because the electrons are free to move, so they can easily conduct the electricity even in the solid state. That's why we are using copper in for using the electric wires, because the copper is a very good conductor of the electricity. It loses the two electrons, so it will conduct the electricity fast. So and also the metals are the good conductors of the heat. So as it is having the mobile electrons, mobile means it can easily move. Mobile electrons, the free electrons, so it will take the heat all over the metal and it passes the heat from one place to another.